Hello. So this is me, Malvin. So this is about unidirectional data flow, and so in this talk, I'm going to talk to you about my journey, like discovering this pattern. This journey took about 1.5 years, I reckon. So and also, yeah. So first of all, I just want to say thank you for all of you to be here and making this event happen because it's been amazing, and I'm just such a honor to be here. So me, who is this guy and why do you care? So I worked for the BBC. Prior to that, I worked for a company called Good Boy, and I was making HTML5 games with them. And before that, I worked for a library called Phaser, which you might recognize, if not anyway. So I worked for the news part of BBC. Because BBC has like many different departments, and there's sport, there's obviously television. So I work for BBC News, the website, so create interactive articles that go, editorial articles. So before that, as I said, so I was making HTML5 games in the world, so this is where I used to work. We're in the world that, was very object-oriented, which usually, because games generally require that. So I made a lot of games, and things were pretty resilient because games are tricky. But then, I first got started programming using base Flash. So as I said, everything was very object-oriented, and so far it worked. It worked. It was really resilient. Games could get tricky, especially when I made games for young children and this sort of audience. So far we're quite happy with our style of coding, but still somehow it became a bit, So suddenly I could see about 2 years ago a shift in the industry. People were talking about things being functional, programming had to be functional, it had to be immutable, it had to be declarative and reactive even. So I kind of I felt a bit overwhelmed, and I kind of retired into the background. Okay, because everything felt a bit academic and using lots of new words, and I felt like it wasn't really for me. So I kind of I looked at the discussions, but didn't really want to step in and get into it just yet. So then this guy came up. So this is Nicola Isayev. I'm not sure if you know him. So he's the author of quite a lot of NPM modules. So Nodes Package Manager. He does a lot of things with 3D graphics. He's a part of StackGL, which is a WebGL kind of environment. And as someone who makes games, I really like WebGL and 3D graphics. So he did a talk at PlotCon 2016 where he introduced his library called Regal, which we're going to have a play with later. At the moment, just want to, as I have a bit of your attention, I'm going to go over the theory, a little bit. So this library claims to be functional reactive WebGL. I was like, wait, this is interesting. I wouldn't have thought of WebGL being the platform to do this. So this was kind of in the back of my mind, started playing around with it. And then later, the React madness sort of began. React went from being a Facebook thing to being the industry standard that it is today. So as you can see, React's the whole environment that's all made by Facebook has many moving parts. So these are all the logos of things that are associated with React, and it's you don't have to use all of these things together, but they're often referred to and kind of made to interact with each other. So in all of this, as I started to dig into it, one guy stuck out, and it's Redox, which I think was a really interesting way to do things differently, because what is it? So it's a state management library. So it manages your state across your application. So you have state in many parts, and it's a central way of managing it. Because usually you have MVC, right? Which is the only thing I knew. And so you have your model, your controller, your view, and they all communicate. But sometimes the view talks to the model, which kind of gave the rise of what were called the MV star frameworks in JavaScript, which meant they could basically bypass the controller. And so things were still kind of communicating kind of in a circle. So everything the way things worked in all directions, basically. That's the point I'm trying to make. So the way Redux works is very different. So it all starts in the view. Imagine you have a form, when you have to enter your info. So the first field will be title. And you'll have a drop down with Mr. and whatever. So I'll select my title, I say Mr., so I click on that drop-down. Then what happens? The view will dispatch what's called an action, which is basically a message. Then it will go to a reducer, which is the way which is the transformation of your data. From there, it'll create a new state object and put it in the store, and that store would then talk to the view. So this is like the broad kind of top-level overview. So the actions. So they're basically objects, that they are JavaScript objects with a name and a payload. So in my example, what I would do is like if I say title selected, so if I select my title, sorry, the name would be title underscore selected, and then the payload would be Mr. So it's basically a message describing what just happened, right? And then this goes to the reducer, which is a pure function whose sole purpose is to transform your data and return, and from what happened, return a new state. So state would be, I don't know, the title would be what I selected. So you have like now this state object that was created here. And because of this pure function thing, so a pure function, just in case, is a function that like shouldn't have any like weird side effects. If you write 100 times with the same parameters, it should output the same result. And this is a constraint. The other constraint that it has to return a completely new state. There is no mutating anything, it just returns something that's brand new. So that state object is then stored in the store. So it's usually a JavaScript object or a dictionary, depending on what language you come from. As I said, it's immutable. And because of the reducer thing, because of everything, you're always putting in a new copy in, you basically get the history for free. So all the like undo, redo is really easy to implement because you have a copy of everything that happened. So all of this basically comes for free. So this is the Redux way, really. So it's the whole unidirectional thing. Things can only go in one direction, and it only works one way. So things cannot, like, it's again, this is not the only way to do things like in a unidirectional way, but it's kind of enforcing it because it's quite like contrived. It's trying to help you from doing unintended things. And I really like this because you can see things can only go in one direction. It really helps like when your state is like all over the place. So as I said, I wanted to talk about Regal, which is like a functional reactive way of doing WebGL and 3D graphics. Because historically, 3D graphics in games relied on scene graphs. So if you've worked with Unity or Unreal Engine, things were pretty much made on the scene graph way, right? Because it's very close to what you're used to. And if you've ever opened a 3D modeling software like Blender, you'll see that everything is it has nodes, lights, everything is part of a global scene. So your state is like all over the place. So this is how we did this in JavaScript for the past 4 years. And so this is 3.js, but it doesn't really matter what it is. The thing is like you create a scene. If you go down and you create a camera, give it a few parameters. And so then you create a renderer, then you attach that camera to the scene. Then you're creating, so if you want to create a shape, we call it a mesh, doesn't matter, but then you create a shape, add this to a scene, then your renderer will render your scene and your camera. So things are kind of like, again, a bit harder to maintain. So now demo time. So here I've got a basic, so there's nothing here. So I'm requiring Regal. And I've just created a Franklin shader because I don't want to bother you with this. So what we're going to do, we're going to make something in 3D that is reactive and like manages state in this unidirectional way. So to kind of get started, so the first thing I do is like add something because there's nothing at the moment. So I'm going to add a background. So it's going to be regal.clear. So this, it's clear because it's kind of like washing the screen with a color. So the first thing you want to do is clear like what's called the depth. So you are clearing it in the z-axis as well. Then you want to clear it with a color. Oh yeah, by the way, this might contain like flashing lights and things like this. So if you have any problem with that, like please, do what you need to do. So so a color is basically 4 values. So we're going to use black because reasons. Right, we have a black screen. Amazing. Okay, so you probably heard of FPS before if you played games. This is running at 30 FPS. Blah 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 blah. So F means frames per second. So you need something that runs 60 times a second in order to animate. So Regal gives us this very nicely. It's called regal.frame. So it's a function, so it's giving it a callback. So this function is going to be called the function that's inside here. Is the size okay? Do you want me to make it bigger? Oh, I'll make it bigger anyway. Yeah, okay. So yeah, so if I put this inside here, you won't see anything because obviously I'm just putting black, a full black screen 60 times a second, which is invisible to our eyes. However, if I did this really horrible thing and I add a random color to that, it won't be for a long time, I promise. You get this horrible flashing thing. And then that just means, okay, it works. There's something happening 6 times a second. I'm just clearing it with a new color. I'm not going to do this because I don't want you to have any issues. So then, okay, how do I draw something? So historically, I create a mesh, something, add it to a scene, create a scene. So this is kind of different. So the way it does it is, so you create something called draw calls. So you create them individually as declarative objects. So first, I need data. So I'm going to need to draw a sphere. So I'm going to use something that allows me to create create sphere, right? And so this is I'm just using a module in NPM called primitive icosphere. So this will give me a function that I could use to create some spherical data. I'm going to create set spherical data, const sphere, and to create sphere. And I'm just giving it a radius, doesn't really matter. So okay, so I get some sphere data somewhere. Okay, it's here, great. Now, as I said about with the mesh the mesh thing. So in order to create your said draw call, the way you draw sphere, you're calling Regal. This is when it's getting interesting. So you're going to need a couple of things. So I'm going to need to pass that data around. So the spherical data, which is if you're in your 3D modeling software, this would be your geometry. So I'm going to pass that data around to whoops again, to WebGL, as a form of attributes, doesn't really matter. But so the idea is that I'm going to pass in the position data as sphere.positions, and the normal data, because that's for lighting, sphere.normals. Okay, so then I'm going to need a couple more things, unfortunately. I'm going to need a vertex shader. I'm not sure if you've heard of that, but if not, don't worry, it's going to be okay. So vert, okay. Then I'm going to write some obscure shader code, but it's okay. So these attributes, so one is called position, one is called normal. They're all 3-dimensional vectors. I need to do some float thing first. So they are all 3-dimensional vectors. So I could just do attribute vec3 position. And then so same thing for this normals. So you see, so this here is going to be passed into the shader right here. So then I need a draw function. So it's a bit low level, but you'll see it's going to main. It's going to get interesting quickly. So GL underscore position. So you need a vec4. Don't ask me why, but that's what you need. Okay, so now we should almost be there. So GL position, okay. So now still nothing, obviously, because this is just so I'm just creating a representation of this draw call of what's going to be drawn on screen. Vertex shaders tell you what to draw, and the fragment shaders tell you how you draw them. But because I don't want to bother you with all that fragment shader code, I packaged it up somewhere else. So great, now I made a mistake somewhere. It's amazing. Fragment shader, right. This always happens. Yes, okay, right. This is because I need to pass that normal around. V-normal. This is for lighting. It's going to make sense very soon. Vic3. V-normal. Okay, perfect. So there's something there. We don't know if it's going to draw a sphere or not, but it should draw a sphere. Oh wait, I need something else. So from the sphere, I need to be able to give it so I need to be able to join the data. If it doesn't make sense, don't worry. It's not really crucial. And now finally, I can call draw a sphere, and if everything goes right, yay, we got a sphere. on the screen, finally. So I promise this was the most like kind of like boilerplate step. So we have a sphere, but what happened? Everything that you can see here is it's explicit. It might not make a lot of sense, but it's explicit in the sense it's declarative. Like so this is the vertex shader, this is the fragment, this is my data. So everything is quite like self-contained. And so now I got a sphere, perfect. Now, in order for it to make it 3D, I need to add a camera. And so the way things are going to work, so you're going to need to create some data for the camera. The camera is basically two matrices. It doesn't really matter because I found a way to like speed this up a little bit because you don't want to watch me type like matrix stuff. So, oops, obviously I forgot stuff. So everything you'll see, you'll have access to the repo at the end. Everything is in branches, so you could just go follow along. So, ta-da, magic. So what happened there is that here, so I create a camera and I create a way to set it up. So in order to add something to my state, I can create a base state, which is basically, so it's called context variables. So here you can see that I gave it values from the camera. And now, so these values are stored in a state again. But in order for this to be passed around to the sphere, this is where the magic happens. So by calling this as a function first and passing the other one as a callback, I like set pre-state variables that are added to the next one. So I can then access them here. You can see Regal context. So this is your sphere thing. So this is basically grabbing it. So this is basically grabbing it from here. And this is good because we like things to be separate. We don't want things to be all in one file, otherwise it would be kind of a disaster to maintain. So now we have a camera, and then now it's in 3D. Cool, okay. So one sphere is kind of lame. So if I want to add more spheres, the beauty of this is now that we have this draw call here that's really explicit. If I want to create more, I could call this function in a for loop, yes. But what I want to do is I could directly give it like a number of times for it to be run, so it's going to be managed internally. So now it's being run 200 times. But what's happening is obviously because they're all using the same position data, I'm drawing 200 spheres in the same place. So I need to add another of these weird shader variables. So we're going to need an offset for each time this function was called. We're going to need a different offset. So we add this to the position of the sphere. So don't worry about this, props. And then this is where, so we get this I variable that we would in a for loop, but things still remain kind of understandable. So now what I can do is I can return another 3D vector. So I times, I don't know, 4 or something. 0, 0. Okay. So now all I need to do is, I'm going to put in here, grab this offset. So, oops, like 3 offset. And then I'm going to add this to the position. And now we have 10 spheres. Oh, 200, but I'm just not going to zoom out because this is a pretty boring way of laying out things. Just again, I'm just increasing the x position because you get so these 3 elements in the array are like so x, y, z. So okay, so now we got this. There is a more interesting way of laying out like objects in space, and so I'm going to use like a spiral function. It's called a phylotaxis. Don't ask me why. Not that require. But then so things should be arranged a bit more neatly. So now instead of returning this like boring vector, I'm going to return phylotaxis of I. And then yay, okay. Now we got a spiral. So it's looking a bit more interesting. And it's in 3D, and so far I've written 69 lines of code. I mean, obviously, so I'm relying on these like external modules, but they're kind of really small, and it's mainly because I don't want you to like look at me writing them like so. But essentially, this is quite readable. Things like the way your state is managed is still in one file in one place. So okay, we got this now. Maybe we should add. I think maybe we should add sound to that. So it's so then it becomes a bit more more interesting. So, okay, let's create a sound player. So, nope, create player. So the same way you have this like create sphere, create camera, so create a player. So web audio player, another of the magical npm modules. So yeah, you'll be able to do this, at home because it's going to be all in the repo. So I'm going to create a player somewhere like here. Nope. Create player. So I'm going to give it a sound file to play. So my sound file is here. It's called Blue Jeans. It's an MP3, right? Okay. So so nothing's playing yet because the sound is not ready yet. So what we're going to do, actually, I'm going to move this down. So now that I got my player loading this sound, when the sound is loaded, so unload it, I get a callback. So I'm going to initialize everything when the sound is loaded. Okay. So then I need to connect things. So I need to connect. So it's web audio. So for this, it won't be any surprise. But I need to connect. So nodes connect, and I need to connect it to basically the speakers of my computer. So player dot context destination. Right. Okay. Oh, what did I do? Got this wrong again. Classic. It's okay. And again, as usual, if you're ever finding yourself doing some live coding like this, make sure you get some backup. So I do have some backup. So there you go. So now, okay, the sound doesn't work, but should be loud enough so you can hear it. Okay, so I got some sound. Right. Now, what if I want to make these spheres move with the sound? And I can do that, obviously, so I can create an analyzer on top of this. So const create analyzer. I can just require analyzer. Right, okay. So now that I created this player, I can create this analyzer. So I just const analyzer. Cool, to create analyzer. So obviously, because in order to know how to react to sound, I need something to tell me. So these are the frequencies that are playing. So you can now make your spheres move accordingly. So now create this analyzer. I can then get yes, and then what I can do normally is I should be able to get the waveform of the sound that's currently playing. So if I can console log that. Obviously, I cannot find it. What's happening? Yes. It's probably not called analyzer, as I'm guessing. Create analyzer again here. So create analyzer. Yes. Right. So there's something that's not erroring, and if I open my console, I get an array with the frequencies of the sound that's currently playing. Now, so I'm going to make, I have 256, so I'm going to make, basically going to make a sphere for each. So now what I'm going to do is pass in, so every frame as the sound plays, I need to get access to those frequencies. So const frequencies, waveform. Yay. Okay. So now, if I give it the frequencies, so it's same. It's just going to draw them, but it's not going to affect them again. So, following this logic, so adding something to your positions, to your state, what I can do here is give it. So because I'm passing those frequencies here as a parameter to the function, they're again following the same context variable that we used for the camera variables, which are set up here. If I give it an array of objects as a parameter here, for each draw call, I can get access to this here. So it's going to be on props.frequencies, frequency, props.frequency, and it should just work normally. Yeah, so you can see it's moving a little bit. So I just need to increase this a little bit, and then I do times 4. No, didn't work. What's happening? What did I do again? Something else. So there you go. Okay, we'll just put the sound. So you can see, like, it's a bit better when you hear it. So yeah, so you see they're moving like to the beat, and just making a bit. Or so that's it, and all your state is in one place. Like there is no like player here and something there and something there and something there. So yeah, so this is like one of the reasons why I really like this pattern, because everything is centralized and goes only in one direction. And then can I present again? So yeah, that's going to be it for me. So feel free to check those links out. There's the links to the slides and also a link to the demo. So if you want to open it up at home, play around, feel free to hit me on Twitter if you need anything on that subject. It's something that was new to me. As I said, I went from being on the object-oriented side and went to learn to enjoy working with these technologies that do things in a different way. So yeah, that's me. Thank you very much.